Good evening. You know, every now and then a story comes along that sounds like pure science fiction, but it's not. It's happening right now. We're talking about a huge shift in how we think about space. And it all starts not with some massive explosion, but with a bag.
And that right there is the headline. The next gold rush, it isn't going to be on Earth. We're talking about trillions, with a T, trillions of dollars in resources just flying through our solar system. And for the very first time, we've got a real, workable plan to actually go out and get them.
So here's the bottom line. There's a private company, TransAstra, and they have a credible, tested plan to go out, capture an asteroid about the size of a house, and then tow it to a spot right near our planet.
And let's be clear, we're not talking about grabbing a few space pebbles here. The target they're aiming for has a mass of about 100 metric tons. To put that in perspective, that's about the size of a small house. And believe me, this is just the very beginning.
You see, the real goal here isn't just about bagging one rock. It's much bigger than that. It's about kicking off a self-sustaining industrial revolution in space, using resources that are already in space. Imagine it. Instead of paying the massive cost to launch everything from Earth, we could just harvest raw materials that are already out there. That completely changes the game for space exploration.
Okay, so you're probably wondering, how on earth is this even possible? Well, the answer lies in a piece of tech that's surprisingly simple in concept, but incredibly advanced in its execution.
I mean, think about it. How do you catch a house-sized rock that's hurtling through space? It's one of the biggest challenges in engineering. The thing you're trying to catch could be tumbling end over end, it's probably got a weird shape, and it's moving incredibly fast. A simple robotic claw? Yeah, that's just not going to cut it.
So, TransAstra's solution is something called the capture bag. The best way to think of it is like a super advanced, incredibly strong inflatable container. It's made from tough stuff like Kevlar and aluminum. The beauty of it is its versatility. You can just fly it over a target, no matter what its shape is or how it's spinning, inflate the bag around it, and cinch it shut. Job done.
And here's the crucial part. This isn't just some drawing on a whiteboard. This technology has been tested. A 1-meter prototype was sent up to the International Space Station, and it worked perfectly, opening and closing in the vacuum of space. That test was a massive milestone. It proved the basic idea actually works where it counts.
This isn't some wild shot in the dark either. The company has really thought this through, breaking the whole process down into 4 clear stages. First, you've got to find the right asteroid. Second, you capture it. Third, you move it. And finally, fourth, you process it. They've actually got patents covering all 4 parts of that plan.
All right, so let's talk about the actual mission that's going to put all this amazing tech into practice. It's called New Moon, and really, it's a huge first step. And the goal for New Moon, well, it's ambitious. The plan is to relocate a 100-ton asteroid into a stable orbit near Earth. Why? To turn it into a robotic research and manufacturing outpost. Basically, a workshop in space where we can figure out the best ways to process materials and build things in space.
Now, TransAstra isn't trying to do this all by themselves. They've put together a global partnership to study if this is all feasible. And we're talking about some real heavy hitters here. The University of Central Florida, Purdue University, and even NASA's Jet Propulsion Laboratory. When you've got partners like that on board, you know this project has some serious credibility.
And they're not waiting around. The timeline here is pretty aggressive. The feasibility study? They want that done by May of 2026. Actually, meeting up with the asteroid could happen as soon as 2028 or 2029. And looking ahead to the 2030s, the big vision is to have hundreds of these robotic missions out there, gathering millions of tons of material. Just incredible.
But here's where it gets even more interesting. This capture bag technology isn't just a one-trick pony. It has another job it can do, one that's just as important. It's a perfect example of dual-use tech.
So on one side, you've got asteroid mining. You can harvest water for rocket fuel, metals for construction, minerals for things like solar panels. But on the other side, you can use the exact same bag to solve another huge problem: orbital debris. We're talking about cleaning up all the space junk, the dead satellites and fragments that are threatening the satellites we rely on every single day.
And this really gets to the heart of it. A quote from Daniel Britt at the University of Central Florida puts it perfectly. He says, if we can learn to use resources that are already in space, it reduces the need to launch everything from Earth. And launching stuff from Earth is always going to be expensive because you have to fight your way out of our planet's deep gravity well.
So when you step back and look at the big picture, what you're seeing isn't just one new piece of tech. No, it's the start of an industrial revolution. Just this one's happening up above us.
And if you want to understand the economics of this, just look at the numbers. NASA's amazing OSIRIS-REx mission cost over $1 billion, and it brought back about 121 grams of asteroid. Now compare that to TransAstra's new moon mission. They're aiming to bring back 100 metric tons for just a few $100 million. The difference in the cost per gram is it's mind-blowing. It's a total game changer. And this is the most crucial point to understand. The real goal here isn't to bring precious metals back to Earth to sell. No, the point is to process these materials in space, to build the infrastructure for a space economy. We're talking about using space resources to build the next spaceships, the future habitats, the factories, all of it, right there.
So, is this the first real tool for building a true solar system civilization? You know, the last big gold rush started with prospectors panning in a river. This one has a much, much grander ambition. What we might be seeing here isn't just the birth of a new industry. It could be the moment we forge the very first tool to build a real, lasting civilization beyond our own planet.